Some of you did and some of you didn't, and that's totally fine. Not worried about it, but let's take a look at the titration from Tuesday. So we took a look at this, and I asked you to get some data together. And so what we had was we had a known amount of acid. Oh no, known amount of, we had a known amount of acid that we added. So we had 30 milliliters of HCl, and we kind of compared this to that. So what I'm gonna do is I'm gonna switch over to my spreadsheet because all of us will have the same data here. So we had, no matter what we did, 30 milliliters of acid, okay? And they told us that we didn't know the molarity of that acid, the concentration. And remember, molarity just means moles per liter. Okay, we'll talk through that in a little bit. So in all of our trials, so I'll add that in here. Let's add one to the left. So in all of our experimental groups, I asked you just to do the odd ones. Right, the first one, let me word wrap, and then I'll share this with you guys. Let's wrap that. Okay, so this is the thing that we don't know. We're going to look for this column. So I'm going to highlight that just so that we remember that that's what we're looking for. And then this other stuff we will know, okay? And so this is my first experiment, question number one, like the first experimental group. And then we're going to do the balanced equation. That should be the same for all of these, I believe. And then there's a volume of the base and the molarity of the base. So let's see what they told us here. Yeah, they told us that the molarity was 0.2 molar. Okay, so if I look at solution 3, I don't think that the molarity changed for you guys. No, it didn't. So we can make all of those 0.2 as well. So let's see here. So this is 0.2. And the volume of base is something that's, the volume of base is going to be something that's different depending upon how much it was in the burette. Okay, so over here, that volume of base, this comes from the burette. So that's that tall, long thing there. Okay, and then the balanced equation will be the same for all of these, and we'll talk through that real fast. And then what we're looking for is we're looking to go back here to the molarity of the acid. Okay, so I've got a little blank page that I found on the internet so that I could annotate a little bit. So we're gonna mix, so the first thing that we need to do is we need to write down what the balanced equation is. Well, hydrochloric acid, if we looked it up, is HCl. And we're gonna mix it with sodium hydroxide, that's NaOH. I could have you guys whiteboard this, but I figured we can just talk through it real fast. So HCl consists of 2 ions. They are H plus 1 and Cl minus 1. And NaOH consists of 2 ions. They are Na plus 1 and OH, sorry, I'm writing with my mouse, minus 1. Last time I hooked my iPad up, you'll recall that it blew apart my iPad and the computer, and I ended up having to log out. So we're gonna just draw with my mouse now. So we can only have, if we could, on the other side of this, we could have H plus and Na plus, but 2 pluses are gonna repel each other, right? We could have H and Cl, but that would give us exactly what we have here. So there's only one choice, and that's the H plus 1 and the OH minus 1 to combine together. So we form HOH, because they're 1 to 1, right? And Na and Cl can go together, and just because we always like to keep things exact, you know, like not exact, but we follow rules, right? The positive comes before the negative. And the way that I always remember that is you want to be positive and leave your negativity behind you, all right? So we want that negativity to be behind us so it goes second, okay? All right, so we're good on that, maybe. That should all be pretty good review. So we're using all of those skills that we learned earlier of how to do all this stuff. And then what, draw Where's my drawing tool? There it is. I think this is it. Okay. So now, from our lab, we said that the molarity. Let me go back to here. We said that the molarity of the acid was what we didn't know. So we don't know. We don't know the number of moles in 1 liter. So that's what we're looking for, is the number of moles of this stuff in 1 liter of solution, okay? Just like we don't say you go 2 miles, we went 2 miles, we say we go, oh, I went 20 miles per hour. Like that's the speed. So this is kind of our concentration is always in 1 liter, okay? But we do know the NaOH, and if I go back to I'm gonna assign this to you guys real fast. And then I go back to these tests. I remember that my screenshot showed me that we used 20.1 milliliters of the NaOH. So 20.1 milliliters of the NaOH. So we use 20.1 milliliters of this. And let's go back and see, did they tell us in the lab, in this thing, they told us that the sodium hydroxide was 0.2 molar. Okay, so that's kind of important. So let's go back here. So they told us that this one was 0.2 moles in 1 liter of NaOH. So all of this goes together, okay? And then over here, the HCl, well, if I go back and I look at my data, here, we said that it took, we said that it was 30 milliliters, right? So it was 30 milliliters of the HCl. Okay. So we can make this into a for every statement, compare it against this, and then we know the number of moles of NaOH. Okay. And then once we know the number of moles of NaOH, the ratio is 1 to 1. So that'll give us the number of moles of HCl. So we can solve for this first. It's 1 to 1. So this should be the same. So solve for this first. And then we just need to make this be that. Okay. Do you guys want to try that real fast and tell me if you can do it? Does that sound reasonable?
Yeah.
Okay, why don't you try and just do this first part here real fast. So write a for every statement for this, compare it to this. So remember, there's 1,000 milliliters in a liter. I'll give you that hint. And I'll give you a couple minutes to see what you can do with that, and then we'll talk through it. I'll leave the screen up, but I'm gonna stop talking for a minute. Okay, we got an answer yet, or maybe? Any brave volunteers to tell me? So let's just talk this through before we even do any math here. Should it be bigger or smaller than 0.2 moles? Okay, forget the word moles. If I told you that there were 1,000 teaspoons of sugar in 1 liter of Coke, that's not true, but if I told you there was 1,000 teaspoons in 1 liter of Coke, and then I poured you a glass, would you think that the number of teaspoons in that glass was less than 1,000 or more than 1,000?
Less than?
Yeah, it's definitely less than 1,000 because we're pouring out just a small portion of it. So if I tell you that there's 0.2 moles in 1 liter, and I know that this is way less than 1 liter, I should expect that there's way less than 0.2 moles. Okay. So I could write out a forever statement on this to actually figure out what the exact answer is. So I'm going to say for every 0.2 moles, oops, 0.2. So that means that there's 0.2 moles of NaOH. Can you guys see the screen still? I never know what you can see. There is 1,000, oh man, my handwriting, milliliters of the solution. So still hashtag US, right? Okay. And then I know that I don't have 1,000. I got way less than 1,000. So this is 20.1. So that number got a lot smaller. So I'm going to do it times 20.1 over 1,000. And then whatever we do to here, we do to here. So times 20.1. Oh, I think I got to let somebody in here. Hold on. Oh, maybe not. Nope, that's just a reminder that I got a meeting in an hour. All right, times 20.1 over 1,000. Which is the same thing, by the way, as saying 2 over 100. Well, I know 2/10 is 1/5, so this is 1/50th of 0.2, or 2/100ths of 0.2. So 0.2 times 2 is 0.4, and then 100th of that would be 0.004. It's not quite that, but it's about 0.004 moles of NaOH. Okay, and because this is 1-to-1, then this is also around 0.004. Okay, and that 0.004 moles is the number of moles in 30 milliliters of HCl. Okay, so I could say, let's do this in a different color then. I don't want to use the same color. Purple's gonna be hard to see. Pink. So for every 0.004 moles. Oh, let's just think about it this way. If this concentration was 0.2 and we needed more of the HCl to do this, is this going to be stronger or weaker than the NaOH?
Weaker?
Yeah, it's definitely going to be weaker because we needed more of it in order to do it. So all of this, it looks like a bunch of jibber-jab math, right? But realistically, you got to really think through what we're doing. That's why we usually do lab, right? Is it gives us an ability to think through that math and think through the logic of it, so that we're not just like doing math just to do math, right? So that's why I wanted us to do those little pivot interactives. So if this is that, then I'm gonna figure out what do I multiply by in order to get to 1,000. So that's 1,000 over 30. Oh, if you're looking for some goofy game, I'm sure I've mentioned this to you before, but I actually got my kids to start playing it. P-Cross. P-Cross. Do a search for it. Goofy game. 1,000 over 30 is the same thing as 100 over 3, right? Because we divide the top 1 by 10 and the bottom 1 by 10. 100 over 3 is about 1 over 3 would be 1/3. This is 10 thirds, which is 100 thirds. So this is the same thing as multiplying by 33.3. Yeah, maybe. Okay. So over here, we're going to multiply this by 33.3. And that number is going to definitely come out to be smaller. So I'm just going to say that it's, this is some inside baseball here. It's the same. If I think about it this way, the 100 over 3, that might be easier. So this is 0.004 times 100 would be 0.4 over 3, right? But 4 over 3 is way easier for us to think about. Well, 4 over 3 is the same thing as, so 0.4 over 3 is the same thing as 4 over 3 times 1 over 10. If only I had started the year talking about how to do this mental math. Oh, I did. Okay. So 4 over 3, right? Everybody knows where I got the 0.4 over 3 from. So 100 times 0.004 is 0.4. And then I still got the 3 on the bottom, right? So the 3 on the bottom just tells me, all right, well, that's the same thing as 4 thirds times 1/10. Well, 4 thirds is way easier. That's 1.33. Everybody knows that, Mr. Swistak. Well, 1/10 of that would be 0.133. And again, does that make sense? Well, we said, yeah, that there's more of this. So this should be weaker than the 0.2 moles. And look, it is. Holy cow. And again, this isn't exact, because when I want an exact answer, I can come over to the spreadsheet and do that. Okay, so this is 0.133 moles in 1 liter of HCl. All right, I'm gonna erase, I'm gonna clear this out, and then we're gonna go back and figure out. So we needed to solve for the moles of NaOH first, then we solved for the moles of HCl, and that got us to the molarity. So let me stop this, and you guys might want to open up your spreadsheet that I just shared with you in classroom. And I'm going to come back over here, and then I'll reshare. Uh-oh, somebody's in here. Sonia, you're in here. How did you get in here? Maybe I shared it wrong. Let me see if I did that wrong. You should have got your own copy of this. Oh, I made it so that you guys could edit the file. All right, forget that. Forget that idea. All right, hold on. Don't get in here yet. Let me delete this one. Delete. I wanted to give each one of you your own copy of it. Hold on. Sorry about that. So create assignment. Now you get to see how the sausage is made. To analyze your experimental groups, right? All right, so let's see, add drive. There we go. All right, I want to make a copy for each of you. Sorry, I clicked this one because I'm out of practice on this. All right, so now you should have, don't forget to submit this too today. Oh, I forgot to put this in under summative. Sorry. Let's see if I can do that now. I can. Good. All right. Okay. Go ahead and open that if you want, and we'll go from there. So I've got my. I'm missing somebody. Nope. I don't want to answer a phone call while we're in here. All right. So I'm going to go ahead and get my date. So we said, all right, I'm looking for the molarity of the acid, but in order to do that, I needed to solve for, so again, this 20.1 was what we got from when we did that. So in order to do that, I needed to solve for the molarity, the moles of the base, right? And from that, I could solve for the moles of the acid. And from that, I should be able to go back and get the molarity. So this is my first thing to do. And then this is my second thing to do. And then over here, this is gonna be my third thing to do. So I gotta figure out, and that's why I always tell you guys, you gotta think this through and you gotta do just one of them. Once you got that one down, you can do it again and again and again. You just repeat the same process again and again. And we let the computer do that for us. So even the people that are making these tests, right, to analyze for this this virus, right, this is what they're doing. They're coming up with, here's how I think you should do it. Here's how we do it. Let's let the computer do it for us once we have it all set in our brain as to how to go about this. Okay, so we said that the molarity of the base compared to the volume of the base, we said that for every 0.2, there was 1,000 of these, right? And then this is gonna be the other. So this is where we're going. So we're gonna say, okay, I need to take the 0.2, the 1,000 first, okay? So equals 1,000 times, oh, no, sorry. This is gonna be equals, yeah, it's 1,000, sorry. It's 1,000 that we're starting with, right? Times, if I can find it, there it is, Shift 8, Mr. Swistack. All right, and then, oh, no. Sorry about that. If we think through, we had to go 0.2 times, and then we had this value, we were going from 1,000 to 0.2, so that means that we had to multiply by the 20.1, and then we had to divide by 1,000. So we're gonna do that divided by 1,000. Oh, there we go, 0.004. I remembered that. So we're good on that. So that's the number of moles of the base. And then from our balanced equation, we knew that there was 1 HCl to 1 NaOH. So that's gonna be the same. So I'm just gonna say it's this, and I'll just put it in here, times 1 divided by 1, because it's 1-to-1 ratio, okay? So 0.004 is the number of moles of acid. And that's the number of moles that was in 30 milliliters. And we want it for 1,000 milliliters. So I'll put it next to it just because that way we are here. I just have to recopy it back to the beginning. So the molarity of the acid then is going to be equals, okay, so we've got this many moles of acid. So we said that that was 0.004 times 1,000 divided by however many milliliters of acid we started with, which was right here. So it's 0.134. So we were pretty close. We said it was 0.13, right? I think. So 0.134. I'll go back and put that in here. I just want to go ahead and copy what I got here. There we go. All right. You're going to fill in the other experimental groups with the data that you got. You're going to do all the, you don't have to do all this work. We already did it together. So you should be good to go from there. We'll practice a little bit more with titrations next week, and we'll do a quick little lab. You guys want to do a quick little Kahoot?
Wait, really quick, can you show the
Sure.
equation for moles of acid, please?
Oh, sure. Yeah, let's go back to this to get to the moles of acid.
Yes, please.
Okay, sure. So we said that for every blank moles of HCl, there is 1,000 milliliters of HCl. And we want to know, we had the number of moles. We had the number of moles in 30 milliliters, which we said was 0.004. Okay. And recall that these things are not constant. They're going to change depending upon which experimental group we did. So the 30 milliliters came from C2. So I'm just going to note that. This is C2. And the 0.004 is the number of moles that we solved for, which was right here, H2. So I'm gonna go back and I'm just gonna say, hey, this isn't a constant. It's a constant for this particular experimental group, but this is H2. So that way later on, when I put things into the row of 3, I don't have to continually go and reference that cell. So over here, I'm gonna go from times 30 divided by 1,000, which will be here for this one. It's going to be times, and that 1,000 here is a constant. That is a constant. That's like saying per hour, which is 60 minutes. We'd say literally, you know, we don't say, hey, it's arbitrary. An hour is arbitrary based upon the experiment. No, we say an hour is 60 minutes. It doesn't really matter. No matter what, an hour is 60 minutes. We're not saying that sometimes an hour is 30 minutes and sometimes an hour is 60. No, it's always 60. So this is 30 divided by 1,000. So if we think about this in terms of our experiment, right, or our spreadsheet, you know, this is nice for this particular one, and now we have an idea of what this is, but this is really times C2 over 1,000, which means that this is also times C2 over 1,000. So this is going to be equals, well, we started with 0.004, but really we started with H2. So this is going to be equals H2 times C2 over 1,000. I got to let somebody in. Somebody's ringing the doorbell. All right. And that's where we left off. Tyson, does that help?
Yes. Thank you.
Thanks for asking. That's awesome. Yeah. We definitely want to make sure everybody gets it. And that's why we spent all this time this year talking through spreadsheets and doing all this stuff. Because next year when you're in physics, that's definitely going to be something that you need to be able to do. And if you can get this down, this is really analysis of data, right? Like you think it through, you write it all out, and then you make the computer do all the work for you so that you're not sitting there with a calculator trying to figure it all out. Your calculator's already there and you built all the problems yourself. Okay, so spreadsheet. So if you didn't do the pivot interactives, get that done. 10, 15 minutes, you should have no trouble. But if you do, let me know. If there's things you want to retake, if there's things you want to redo, if there's things you want me to talk you through, if there's stuff extra work you need, let me know. I know some of you have messaged me and gotten that out. I will get that to you today, and we can schedule a time for you to prove that you have mastery of this concept, okay? And try to get this spreadsheet here, which shouldn't take you very long. Try to get this spreadsheet done and ready to go for me and submitted by Tuesday would be great. And then I'll throw that in as a grade. Okay.